So I'm going to do another example of the epsilon delta definition, trying to find another delta. So this is going to be my second example. So find again, a delta, that's our x values, to show that the limit as x approaches -1, notice that's a little bit different here. Last time we were doing it around 0, this time we're doing it around -1, as f of x equals 0. So in this case, we want our epsilon to be 0.1. Again, that's our y distance. That's how far away from 0 we want it to be. And we're going to use the function f of x equals x cubed minus x squared plus 2. So again, let me kind of switch back to the graph. So here's my graph. I've got it kind of zoomed in already. So there's x cubed minus x squared plus 2. And again, we're looking for the limit as x approaches -1, which is 0. Again, hopefully you guys pick up on the fact that that is a true statement. And so I want to be within 0.1 of this dot here. So I'm going to use y equals 0.1, and that's going to be one equation. The other equation I'm going to use is y equals negative 0.1, because I want to be 0.1 above and 0.1 below this y value that I'm looking for. So if you notice, I don't have a lot of wiggle room in here. There's really not a lot of, I'm going to say, x values that are going to put me within 0.1 of this dot. And so what I'm looking at here, and I'm just, like I said, I'm just trying to look at where it intersects just to try to help me out. I've got negative 1.0196886, and I've got on the top negative 0.979767. So those x values right there are kind of giving me a very, very small window. This one's about 0.0, I'm going to say around 0.04 away from -1. And this one is negative 1.019. So this one's really only about 0.1 away from -1. So that's the number I'm going to try, just because it's kind of the smaller of the two values. So let's go back to my problem. So let me repeat again. I'm trying to essentially use my x distance as 0.01, and I'm just going to see if it works. Again, we're just kind of guessing and testing and seeing what happens. And so what I'm going to do is I'm going to look around this -1, and I'm going to look 0.01 away. So I'm going to kind of do -1 plus 0.01. I'm going to do -1 minus 0.01. So essentially, I'm going to plug in negative 0.99 and negative 1.01. Hopefully, these numbers will work out nicely. I'm just going to go ahead and plug those in and see what happens. So the first one I'm going to plug in is that negative 0.99. So I'm going to do negative 0.99 square, or excuse me, cubed. Should be cubed. And then it's minus negative 0.99 squared plus 2. Let me go ahead and, like I said, I'm going to go ahead and type that in. And I got 0.049601. And now I'm going to go ahead and plug in the other one, the negative 1.01. I'm going to go ahead and try to write it down while I'm typing it in. So I'm going to do negative 1.01 cubed minus negative 1.01 squared plus 2. And I've got negative 0.050401. Now, I'm going to kind of recap real quickly, just very briefly, what I was trying to do. So I was trying to find a delta value around -1 that would give me y values within 0.1 of 0. So let me repeat. So my point was negative 1, 0. And I wanted to be within 0.1 away from it. And if you notice, this right here is indeed smaller than 0.1. And this right here is closer to 0 than negative 0.1. So these do work. So again, my delta value here we found was 0.01. That does work. Again, I know smaller numbers will work. I would even say you could try some bigger numbers like 0.015 would probably work too. I don't want to pick too big. I'm worried if I plug in 0.02, it wouldn't work. And the reason I'm saying that is if I look at this bottom dot again, that would probably be a little too far away because that negative 1.02 is a little bit bigger than that negative 1.019. So again, be very, very careful what numbers you test and what numbers you try. But again, there's multiple right answers you can get for our delta value. It's just about trying to pick something small enough, something close enough to what we're looking for. And again, be very, very careful for how this works. Again, you're using your delta as an x distance, and you're using your epsilon as a y